Hi students, so welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about how to insert a new node in a binary search tree. In this session, we will learn how to delete a node from a binary search tree. Overview of the session. In this session, we see definition of a binary search tree and we see how to delete a node in binary search tree. Outcome of this lecture, at the end of this lecture you all are understand how to delete a node in binary search tree. So what is the definition of binary search tree? So binary search tree is a binary tree have at most two children, a left child and right child. Here the left child or left subtree, the values of a node is less than or equals to its parent node value. In the right subtree, the value of node is greater than its parent node value. So let us consider this example. So 75 is root. Now I want to insert 55, left side or right side? Left side, 55. Now I want to insert 95. So 95 is at right side. Now I want to insert 35. So compare 35 with 75, it is less than, so traverse to left, 35 is less than 55, so again 35 is left of 55. Now I want to insert 80, now 80 is greater than 75, so traverse to right side, 80 is less than 95, so 80 is left of 95. Now I want to insert 100, 100 is greater than 75, so traverse to right side. Now again 100 is greater than 95, so traverse to right side. Okay. So now I want to insert 20. So 20 is less than 75, so traverse to left. 20 is less than 55, again traverse to left side. 20 is less than 35 and 35 left is null, so 25 is left of 35. Now I want to insert 65. So 65 is less than 75, so traverse to left side, and 65 is greater than 55 and 55 right is null. So 65 is right of 55. Okay. So this we call as a binary search tree. When we try to delete a node from binary search tree, we have three cases. So first case, maybe the node to be deleted is a leaf node, or second case the node has one child, and third the node has two children. So for example, this is the tree 75, 55, 95, 35, 65, 80, 100, 20, 40. Okay. So now if I want to delete 40, so this is the leaf node, that comes under case 1. Now if I try to delete, for example here there is 120. Now if I try to delete 100, this comes under case 2. This node 100 has one child, so 120 is child of 100. Now consider this example 77, 98. Now if I try to delete this 80, this 80 have two children, so it comes under third case. If I try to delete 75 also, so 75 have two children, so it comes under case 3. Okay. So these are the three cases we have when we try to delete a node from binary search tree. So let us discuss one by one. So consider this binary search tree. Now here I want to delete this 40. Now so 40 doesn't have any children, so this 40 we called as leaf node. Now how we delete this? We traverse from root. For example, the root is 75. Now I want to delete 40, so 40 less than or equals to 75, yes it is less than, so traverse to 55. Again compare So 40 with 55, 40 less than or equals to 55, yes, it is true. So again traverse to left side. Now compare 40 is less than or equals to 35, no, so 40 is greater, so traverse to right side. Now compare, so 40 is less than or equals to 40, no, 40 is greater than 40, no, both the cases is fail means 40 found. Okay, now so this 40 I want to delete. Now let us assume the address of 40 is 100. Now that address already we store as a right of 35. Now we delete this means we make the root right side as a null. Now if you make the 35 right side as a null, then this connection will be terminated. So after that we delete this node using free function, that is it. So now we see the second case. So let us consider this binary search tree 75, 55, 95, 35, 65, 84, 105, 20. Now I want to delete this node 35. So now compare, so 35 less than or equals to 35, yes, 35 is less than, so traverse to left side. Now again compare, so 35 is less than 55, yes, so traverse to left side. Now compare, so 35 less than or equals to 35, no, is it greater than 35, no, that means 35 is found. Now I want to delete this 35. So before that I check whether this 35 have children or not. How we can check that? If the left address and right address is null, then it is leaf node. But if it have any child, maybe it is left child or right child, let us assume the address of 20 is 100. Now 100 is the left side address of 35. Now this 100 I store as a left of root. What is the root for 35? 55. Now here 100. Now this will be the link and this will be terminated. Okay. Now what is the resultant tree? 75, left is 55, 55 left is 20 now. So 35 will be deleted. 75, so 55, 20. So remaining all are same. Okay. So this is, in this way we solve if the node have one child. Okay. Now coming to third case, that node has two children. So this is the binary search tree. Now I want to delete this 75. Now 75 left is 55, right is 95. So this comes under third case, the node has two children. Now what is the solution? Now here the solution is, for 75 we identify the successor. So successor means identify minimum number in right side. Now what is the minimum number in right side? 84. So copy this 84 into root node. Now 84, 55, 95, 35, 65, 84, 104, 20, 40. In next step we remove this successor from binary search tree. So let us see the code to delete a node in binary search tree. So consider this example. I want to delete this 40. Now 40 is leaf node. Now we see how we identify that. Now so here this is the delete node function root. So let us assume the root is 75. Here I am taking both root node and root data as a same value 75. What is the key? 40. Now I want to delete 40 and the root is 75. Check, root equals to null? No. So root is not null. Why? The root is 75 now. Now we move to here. Check key less than root arrow data. Root arrow data is 75. Key is 40. 40 less than 75? Yes, it is true. So again we call the same function delete node with root arrow left comma key. Key is same 40. So root arrow left, 75 arrow left is 55. Now same function is invoked. Now in this function, so what is the root now? 55 is the root now. What is the key? 40. Root 55 equals to null? No. So move to here. So what is the key? 40, 40, 40 less than root arrow key? 55. Yes. So 40 is less than 55. So again we call the same function with root arrow left. 55 arrow left is 35. Now 35 key is same 40. Now again in this function what is the root now? 35. So 35 equals to null? No. Again we moves to this instruction. So what is the key? Same 40, root arrow key 35. So 40 is less than 35? False. Then we move to here. So what is the key? So 40 greater than 35? Yes, 40 is greater than 35. So again delete node. So root arrow right. So what is the root arrow right? What is the root arrow right for 35? 40. Now 40 comma 40. So what is the root? 40 equals to null? False. Now this is the instruction. 40 less than root arrow key? 40 less than 40? False. Again move to here. 40 greater than 40? False. Now we found that 40 is found in binary search tree. Now so we identify case 1, that is leaf node, then no need to modify, just make 35 root as a null. Actually the right of the 35 is 40. Now make this as a null. Let us see. Now node with 1 and no children, root arrow left. Now so what is the root here? 40. So 40 arrow left is null. Yes, this is null. So it is true. We are taking one temp value. Temp equals to root arrow right, that is a null here in this case. Now root arrow right equals to null. Yes, root arrow right is also null. So temp equals to, we are taking as a left side, that is null. Okay. Now free root, this 40 will be deleted and return temp. So return temp to previous function call. Here the previous function call is 35. So that is this null is written to here. Now root arrow right, what is the root here? 35. Now 35 arrow right is null now, null. Okay. So now, so this is the case 1. Now consider case 2. Now if I try to delete 35, so now 35 has only 1 children. Now we see the same algorithm. Now the key is 35, root is 75 in first iteration. 75 is the root, so key is 35. 75 equals to null? False. Move to here. What is the key? 35. So less than 75? Yes, it is true. So again we call the same function delete node with root arrow left. What is the root arrow left now? 55. So 55 comma key. So 55 comma key is 35. Now again we call the same function. So root 55 equals to null? False. Then move to here. What is the key? 35 less than 55. Yes, it is true. So again we call the same function delete node root arrow left. What is the root arrow left? 35. So root and key is also 35. So both are 35 in this case. Now 35 equals to null? False. So 35, so less than root arrow key? False. Why? 35 less than 35? False. Then we check key greater than root arrow key? 35 greater than 35? False. Now these two conditions are false, that means the element is found. Now so 35 is found. Now we move to here. Now you check that root arrow left equals to null? No, it is not null. So enter into the block and temp equals to root arrow right. So what is the root arrow right? Null. Now temp equals to null. So root arrow left equals to null. Here 35 arrow left equals to null. No, 35 have 20. So it is false. Then we move to here. Root arrow right is null. Yes, it is null. So temp equals to root arrow left. Now we are taking one temporary variable temp. So root arrow left is 20. Now we delete this 35 and return this temp. What is the temp? 20. Return to previous function call. What is the previous function call here? 55. 55. Now 55 in this. So 55 arrow left equals to 20 now. Now this will be changed as 75, 55. So 55 left is 20 now. Now this is the resultant tree after deleting this 35. Okay. So now this is the resultant tree. Now I want to delete 75. 75. So 75 have two children, 55 and 95. And what we discussed in our previous slide, if you try to delete a node that have two children, then we find the successor. Here in this case, how to find the successor? 75, move to right side and identify minimum value in this tree. So that is the successor. In this subtree, the minimum number is 84. Let us see. So what is the root here? 75. Key is also 75. Now root is 75, key is 75. So 75 equals to null, false. Move to here. 75 less than 75, false. 75 greater than 75, false. If these two statements are false, then element is found. So move to here. So this is the node with only one or no child. Now root arrow left equals to null. No, this will be false. It have 55. So root arrow right equals to null. No, it is 95. So both the conditions are false. Then we move to here. Here I am taking one variable temp equals to minimum value node of root arrow right. So how to identify the successor? Move to right side. So here I call one function min value node. This node we call with the help, here I call this function with root arrow right. What is the root arrow right? 95. 95. Now I am taking one current to traverse to left side. So current arrow left not equals to null. If it is a null, we stop. Current arrow left not equals to null. Yes. So 95 is not equals to null. So current equals to current arrow left. Now it becomes as 84. Again you check, 84 left is null now. So we stop here and return the current. Now what is the current? 84. Let us assume here if you have 80, then the 75 successor will be 80. In this case 95 and move to left side, again move to left side. Okay, same algorithm. So now in this case 84. Now 84 is assigned to temp here. Now we found the minimum value node. Now root arrow key equals to temp arrow key. What is the temp arrow key? 84. 84 is copied to root. Okay. So now root arrow right equals to, again we delete node. What is the third step? We delete this 84. The same algorithm. So delete node. So root arrow right, that is 95. So temp arrow key, that is 84. Now I want to delete this 84. So compare 84, again we call the same function delete node. Here in this case, so 84 is a leaf node. I hope you all are understand how to delete a leaf node. So same 84 will be deleted. Now the resultant tree is 84, 55, 95, 20, 65, 104. Okay. I hope you all are understand how to delete a node from binary search tree. Summary of the session. In this session, we discussed how to delete a node in binary search tree. We have three cases. So, case 1 is deleting a leaf node. So, case 2 is deleting a node have only one children, and case 3 is the deleted node have two children.